Problem 38 from chapter 26. A certain wire has a resistance R1. What is the resistance of the second wire made of the same material that is twice as long and has twice the diameter? Here we are going to find the resistance of the second wire. That means we have two wires. The first wire is resistance R1 and the second wire resistance is R2. That value we are going to find. And also they give the additional information. The second wire length is twice the time of the first wire length, and also the second wire diameter is twice the time of the first wire diameter. And the most important thing, both wires are made of the same material. Here, for finding the answer for this resistance, we are going to use the equations that we studied from the theory class. As we already studied, the resistance R, which is equal to the resistivity of the material multiplied by length of the material over the area of the material. If you see the cross-sectional area of the wire, the cross-sectional area is nothing but the area of the circle. So therefore, the area of the circle, which is equal to pi r square. And here in this question, the information is given related with the diameter. So we have to convert this radius in terms of diameter. As we already know, the radius which is equal to the diameter divided by 2. Therefore, the radius square which is equal to the diameter square over 2. So here I am going to take this r square and I am going to substitute this value here. By that, the area is equal to pi d square over 4. Now I am going to take this area and I am substituting the resistance formula. By that, the resistance will take the new modified equation R, which is equal to resistivity multiplied by length over pi multiplied by the diameter square over 4, and this 4 will go to the top. By that, the resistance formula is equal to 4 multiplied by the resistivity multiplied by length over pi d square. Clear? Now here I am going to use this equation for getting the answer for the second wire resistance. Before that, better we can write what is given in the question. So what they give, the length of the second wire is equal to twice the time of the first wire length. Likewise, the second wire diameter, which is equal to twice the time of the first wire diameter. And both resistivity, that means both materials are made up of same material. So the rho 1, which is equal to rho 2, which is equal to, better we can take rho as it is. Here rho is nothing but the resistivity of the material. Now what I am going to do, I am going to write this formula for both wires. For the first wire, I am going to take this equation as R1, which is equal to 4 multiplied by, because here both materials are made up of same material, so resistivity value we can take as it is as rho. And here the length for the first wire I am going to take as L1 divided by 4 multiply for diameter. The diameter of the first wire is equal to, actually here I made a mistake. Here this is not 4, this is pi, right? So 4 rho L1 over pi multiplied by d1 square. We can take this equation as equation number 1. Likewise, I am going to write the same rule for the second wire, R2, which is equal to 4 multiplied by resistivity rho, and here in place of L1 I am going to take L2 over pi multiplied by d2 square. Now I am going to substitute the value of L2 and d2 in this equation. By that, the second equation is modified as R2, which is equal to 4 multiplied by rho multiplied by, here L2 is 2 times of L1. So here I have to write 2 multiplied by L1 over this pi value I am going to write as it is, but d square is 2 times of d1. So here what you will get, this value you have to square. So you have to square this value because here we have d2 square. So if you square this right hand side, you will get 4 multiplied by d1 square, right? So I am going to take this equation is equation number 2. Now I am going to divide these two equations. So I'm going to divide the second equation with the first equation. So divide equation 2 by equation 1. So I am going to divide the left hand side first. Therefore, R2 over R1, which is equal to, first of all, I am going to write the R2 value, 4 rho 2 L1 over pi 4 d1 square, and divide by R1, right hand side of the R1 is 4 rho L1 over pi d1 square. So I have to write this equation in terms of the multiplication form. Therefore, R2 over R1, which is equal to 4 rho 2 L1 over pi 4 d1 square multiply pi d1 square over 4 rho L1. Now we can cancel the same term. So what are the same terms we have? We can cancel 4 with 4. We can cancel rho with rho. And we can cancel L1 with L1, right? Likewise, we can cancel this pi with this pi, and also we can cancel d1 square with the d1 square, and we can cancel 2 here. The 2, 4 will go 2 times from the 2. So here we have 1 over 2. And the remaining all the terms are cancelled out. So here finally we have R2, the resistance of the second wire, over the resistance of the first wire, which is equal to 1 over 2, right? And better we can just go back to the question. So what they ask us to calculate, they ask us to calculate what is the resistance of the second wire. So we have to re-modify this equation, rearrange this equation in terms of the second wire. Therefore, the resistance of the second wire R2, which is equal to, this R will go to the right hand side of the numerator. By that, the resistance of the first wire over 2. So this is the answer for the question. Clear? That's it. Thank you.